On the 8th of May 1984, Queen Elizabeth II officially opened one of the most significant flood defense systems in the world. It marked over a decade of construction alongside many centuries of ideas, innovations and engineering developments that have been in place to protect the City of London from the ravages of the sea over time. In 2024, the Thames Barrier has just recently celebrated its 40th anniversary in a very different world than the one it was designed and created for. The rapidly increasing pace of climate emergency has led to so many of the predictions and projections for rising water levels being ripped up and replaced. In effect, this means the lifespan of the Thames Barrier was based on data from another time entirely, and it may need a big revision. Frighteningly for the residents and businesses of London, it was suggested at the time of completion that the barrier could only remain effective until anywhere between 2030 and 2070. As the information about the 21st century sea levels have come to light, there are several questions currently being asked about the future of this essential guard against the elements. What happens if it does fail? The original predictions suggested we may be only 6 years away from finding out, and that is surely even closer now. How will it work if a disaster strikes one of the most important economic centers on our planet? And when can we expect to replace it? Whatever does replace it needs to be implemented quickly to stand amongst the long line of barriers throughout history that have protected England's famous river. The Thames Barrier is a 520-metre-wide construction located in Woolwich Reach in the London Borough of Greenwich. It spans from Silvertown on the north bank to New Charlton on the south bank, all roughly 8 miles downstream from central London. This area was chosen specifically in response to where the tidal influences could have the most effect on the River Thames's behaviour and to ensure the most protection for the whole city. Without it, or if it is compromised, any significant tidal surge or freak flooding event could spell catastrophe. Very quickly, the areas that rely on the barrier upstream would soon be inundated with masses of water. In the first hour of a flood event, low-lying locations in London, such as the Isle of Dogs and the financial hub of Canary Wharf on the eastern edge of the city, would be hugely affected. With levels rising by several meters, thousands of businesses and homes would be hit hard by the torrent of dirty and uncontrolled river water. After around 3 hours, central London would be approaching disaster. Vital transport networks and infrastructure would be taken out of action. The world-famous London Underground could quickly become submerged with devastating consequences. Within only half a day, the city would reach peak flood. Emergency services would be stretched incredibly thin, and the damage to houses and businesses may be irreversible in many places. Some parts of London may remain submerged for days with no real indication of when the surge will subside and water levels can start to drop. Over 1.25 million residents of London would be at immediate risk, with hundreds of thousands more affected from the dangers and disruption to critical movement networks and infrastructures. Some of the most important and famous landmarks the world has ever seen could be submerged and ultimately sent to their own watery graves. The Tower of London, the Houses of Parliament, and the cultural epicentre of the South Bank all stand perilously close to the waves that may eventually consume and destroy them. Hundreds of thousands of people would potentially be displaced. The overall economic losses would be estimated to exceed £80 billion. And it is safe to say that London would never be the same again, unable to repair back to the important and unquestionable status it now enjoys. For now at least, the Thames Barrier is a formidable line of defence to these worst-case scenarios, with some pretty powerful engineering in use to keep it operational. This is how it works. 10 gates, made of hollow steel up to 40 millimetres thick, divide the river into 6 navigable spans. The central four gates are 61 metres wide, standing at 20 metres high, at a sturdy weight of 3,700 tonnes. The others measure around half the size, at 30 metres wide. These are supported by massive piers that house a wealth of key machinery vital to the operation of the barrier. The pier houses are so large that they take up some pretty big real estate on the London landscape. So, they were designed in striking scale by the late Sir Roger Walters, a leading architect, also famous for the redevelopment of Covent Garden. He wanted to show that even utility on this scale can be created with style and aesthetics in mind. They each contain large hydraulic pumps and cylinders that rotate the gates from a horizontal resting position down on the riverbed to an upright vertical position to block the river during a flood-threatening event. This whole operation, to make the river flood safe, takes around 90 minutes to complete. However, the crucial raising of the gate as a defense can take as little as 15 minutes to implement a solid barrier against damaging tidal surges. The extreme heat generated during this operation means that each pier requires a complex system of cooling and ventilation to manage temperature and air quality for a safe working environment. Remote and manual control systems are also installed to deliver the quickest response time without human intervention, all built with huge motors and backup generators that can be called upon in a power failure. The monitoring systems are perhaps the most important of the pier house machinery. The Environment Agency relies on a combination of familiar and proven forecasting methods and electrical sensor technology to assess any impact on the barrier and the river beyond. An array of weather monitoring systems are fully integrated into the barrier system to record and analyze local meteorological conditions. Wind speed, atmospheric pressure, and precipitation are all logged to help predict when the surge may come, and the barrier has to spin into action. Gate position sensors ensure that they are all aligned to work in concert with each other, providing information on height and overall health of the structure at all times. This is essential to provide the right element of protection without compromising the structure of the piers and gates. The water level and flow sensors that are present both upstream and downstream on the barrier can pass on this info directly to a centralized control room for insights in real time to assess the effectiveness of any protection measures. If a surge is imminent, there are contributing factors, such as the annual high tides of spring, that can make them far worse, so the gates are on continual alerts. All of this incredible construction is joined by 9 smaller concrete piers and 2 abutments that make 4 smaller, non-navigable channels across the width of the river. This divides a huge and unpredictable expanse of water into measurable areas that can be better understood and protected. Much of the development and building of the Thames Barrier was as a direct response to the tragic events of the North Sea flood of 1953. This disaster took the lives of 300 people, flooding thousands of homes and businesses to cause around £1 billion of damage in today's money. It highlighted how vulnerable London was to the merciless surges of the sea, with the Thames bursting its banks in many places, threatening to overwhelm the city with roads and bridges quickly flooded. Shortly after, the Ministry of Agriculture and Fisheries report stated that the 1953 flood made it painfully clear that London and its surrounding areas were at risk from tidal surges and that existing defences were inadequate. Newspaper reports were quick to pick up on the inefficiency of flood defense for the city and the level of danger posed, writing, "The night of the Great Flood revealed the vulnerability of London to the forces of nature, a vulnerability that could no longer be ignored." The Thames Barrier has been used over 200 times since its opening, protecting the city from the consequences of events like the flood of 1953. However, it now stands at an important crossroads in terms of its future use and efficacy. Over 10 years ago, a member of the Thames Barrier project management team, Dr. Richard Blore, suggested it was not designed with increased storminess and sea level rises in mind, and called for a newer barrier to be looked into immediately. Some ideas that have been floated as part of its replacement are maintenance upgrades and the building of an even bigger barrier further downstream. There are even projects being considered that will allow for certain areas to be deliberately flooded, creating new wetland habitats in less populated areas to take the strain and pressure away from any flooding events and surges. Currently, there are no plans to implement any of these measures until at least the 2040s. So for those living and working in London, it could be an anxious 15 years or more until their homes, offices and way of life are guaranteed full protection. With sea levels rising every year and freak weather events becoming more and more commonplace, the next floodwaters to test the Thames Barrier may already be stirring far out in the Northern Sea. So, we can expect to hear a lot more about the future of the Thames Barrier as the clock ticks down to 2030.
Remember to hit the subscribe button and ring that bell to stay updated with our latest content. And while you're here, why not check out another one of our exciting videos? Thanks for watching and see you in the next one.